so it is you. So whatever measurement you're taking from the object to the origin, you're going to take it as negative. Suppose we say it is 20 centimeters. You write it as minus 20. Okay? So you will be negative always. Let's look at the focal length. What type of a lens is it? Is it converging lens or diverging lens? Converging or is it diverging? It is converging. Converging because it's all meeting at a point. You remember rays of light which is coming here? It is meeting at a point on the principal axis. So obviously your F focus is going to be here. Correct? And what is this distance between O and F? What is it called? V. It is your focal length. F is nothing but your focal length. Now is focal length going to be positive? It's obviously positive because it is coming on the right hand side. So focal length will always be positive. Now we have got two options for image. Pay attention to me, okay? So when we are talking about images, you can have either a real image or you can have a virtual image. Okay, so there are two options. So it can be real or virtual. If it is a real image, it is going to be always inverted. Okay, so it is going to be formed somewhere here like this. Is that okay? So if it is a real and inverted image, what will be the sign? For me, it is going to be positive because it is coming on the right hand side. So real and inverted, it is going to be positive. If it is a virtual image, so it is going to be a negative image. So you are going to have a dotted line like this. Okay, magnified image, it is going to be erect. So it is going to be erect and virtual, and therefore it is going to be negative. So these two options are possible for your V. Is that okay? Did you understand? So that's why I'm saying whenever we are doing our word problems, we try to draw a simple diagram like this, a small rough diagram at the corner of the page, so that it becomes very easy for you to identify what type of image or what type of the question or whatever it is that they are asking. Is that okay? What is the difference between a convex lens and a concave lens? Let us see once again. Suppose this is the x-axis and the y-axis. It is a divergent or a divergent. Okay, so this lens is nothing but a divergent lens. So when we have rays of light coming here, it is the rays are moving across, and we feel that the rays are coming from a point which is your F1. Okay, so in this particular case, what about you? Where is you going to be? Is it on the left hand side or on the right hand side? What is you? What is you? Object distance. So where is the object going to be? Always on the left hand side. So we are going to keep the object here, anywhere here. Okay. So you from here or from the object to O is always going to be negative. Okay. Now if you look at the images which are formed by a concave lens, what type of an image is it? Virtual. Virtual? Yes, very good. And it is always going to be smaller than the object. Okay. So we may get something like this, a small one, somewhere like that. So your V here, V which is going to be your image, it is always going to be virtual. And if it is virtual, obviously it is going to be erect. And it is going to be on the same side as that of the object. Object is here, image is here. So image is always going to be on the same side as that of the object. Okay. So which side? Obviously the left side, so it's going to be negative. What about focus? Is it going to be here or here? That is right. You remember exactly opposite right now. Focus on this side, F is here. But here it is going to be on the left hand side. So your focal length here is going to be negative. Did you understand? So yesterday I had given to you that table. Obviously some of you may have the book, some of you may not have the book. But I have given you a table regarding the different signs. Okay. So you should be thorough in this part of it. But then the rest of it is very, very simple. Okay. So in physics children, basically what we are doing is we are trying to test your understanding of the problem that is given. We are not talking about any complicated mathematical equations or anything. Equations, formula, very, very simple. But for us to understand whether it has to be negative or positive, if we make a mistake here, then the whole thing will go. So we have to be very careful in identifying what type of a sign value it is going to take, whether it is going to be negative or positive or whatever it is. Is that clear? Clear, everyone? Okay, fine. So this is something that we have already covered regarding sign convention, and today I'm just going to talk a little more regarding the convergent power. Okay, and how do we find out what is the power of a lens? So if we are saying a lens, suppose we are talking about a convex lens. Okay, we know that it is a converging lens, isn't it? So what does it tell us? That if you are having a ray of light parallel to the principal axis, this is your incident ray. Will it move away or will it come closer? Converging, it is meeting, okay, at a point on the principal axis. So this is how we have drawn the diagrams. You remember the very first diagram? Object is very far, it is at infinity. The ray diagrams, the first ray diagrams are being drawn. The rays are coming from infinity. So we have drawn dotted lines like that. Okay, and this is O. So it appears, because it is of course meeting here, that is your F1 and this is your F2. So it meets, all these rays are meeting at a point, and therefore it is a converging lens. So if you are talking about the power of a lens, what is it? It shows the degree to which it is converging. Okay, how much the rays are converging. So you will notice that if at all the lens is bulging like that, okay, that means the focal length is very small. But if you are taking a very thin lens like that, it is still a convex lens. If you notice, it is still a convex lens. Okay. But if you are talking about a ray of light above and below the principal axis, it is also converging, but it is converging somewhere here. If you notice the difference between this and this. Okay. If it is a thicker lens, the converging power is more. Okay. So compare the focal length here and compare the focal length here. What happens to the focal length here? It is increasing. What happens to the focal length here? It is very small. Okay. If the focal length is small, that means the power of the lens is more. Why do we say power is more? Because it is capable of converging the incident ray. Are we okay here? Yes, clear? Okay. You will be amazed to know something about the human eye, which we are going to, of course, anyway do it in detail in the next chapter. But when we are talking about the human eye, there is a lens like that. You realize? It's a convex lens present inside our eye. So when I'm looking far off, obviously the focal length has to be changed. If I'm reading a book at this distance, focal length has to change. So the human eye is capable of changing the shape of the human eye lens. Okay, depending upon the distance of the object that we want to see. Okay, we'll do a little more about that, but just for you to understand. So how can we calculate the power of the lens? So power of a lens, P, is always given as 1 divided by F. That means it's inversely proportional. Is it directly proportional? No. If F is more, if this F is more, power is less. Okay? If F is less, then the power is more. So what did we understand from that? That it is inversely proportional. Power of any lens is inversely proportional to the focal length. And this focal length always has to be in meters, not in centimeters. We always are going to calculate focal length in terms of meters. So even if it is given in centimeters, convert it into meters. For example, if I am saying focal length is 20 centimeters, how many meters is that? Will you multiply or divide? In meters, I want it in meters. Divide. How many? So you have got 100 centimeters is equal to 1 meter. So 20 centimeters. So 20 centimeters is equal to 20 upon 100. So how much is it? 0.2. Did you understand? So it is going to be 0.2. Okay, in meters. So when I'm writing there focal length has to be in meters. Remember that you are going to convert this and then not into meters. Is that okay? Did you all understand? Okay. So this power that we are talking about, though we are calculating P is equal to 1 upon F, which is in meters, the unit here, we are going to write it as diopter. D. Capital D is your diopters. So you may have somebody saying, "Arey, my eye lens is 1.25. They may say it is negative or positive. Maybe your friends may say, yeah, my glasses are, let us say it is 1.25. You may say it is plus. What does it mean? What do you think it is here? If it's going to be plus, if focal length is plus, is he using a convex lens or a concave lens? If F is plus, where do we get F and plus? Concave. Convex. Where is F here? F is positive here. Did you understand? What is F here? Focal length is positive, isn't it? If F is positive, that means it's using a convex lens. Okay. Suppose somebody says that the power of the lens, okay, in diopters is minus, let us say 2.5 D. What type of lens is he using? Negative either. So, concave. Understand? Okay. Understand? All of you got it? What I'm saying? Always remember, for a convex lens, focal length is positive. For a concave lens, it is going to be negative because the F will come on this side, isn't it? On the left hand side, so it is going to be negative. Okay? Come on, let's take up one of them. Write down. I'm on page number 155. If you're all with me. Lens formula and magnification. Just before that, we also have got sign convention for spherical lens. Do you have something to write? You have something to write? I'm dictating something. Okay. Make sure that you stick it up to today's date. What is today's date? 18th. Write down there. 18th. And write down it is in continuation. Okay, and write down their page number 155. So that we know that it is in continuation. Okay. Sign convention. I'm reading the sign convention. All of you pay attention. For lenses, we follow the sign convention, which is similar to the, look at your text, spherical mirror. Did you get it? Which paragraph? We apply the rules for signs for distances, except that the measurements are taken from the optical center of the lens. Try to recollect for mirror, what was the point of measurement? C, not C. What will we say? P. C is center of curvature, but our distances were always measured from pole. Okay, so now here what do we use? We use the alphabet O. What is O? Optical center. Okay. Right. According to the sign convention, the focal length of a convex lens is positive. Underline. In your textbook, please underline. Nish, you want something? You have a textbook with you? Okay. Just underline that one. Okay. And that of a concave lens is negative. F is negative for a concave lens. Okay. You must also take care to apply appropriate signs for the value of U, V, F. And for the object height positive either or negative? Object height positive. Okay. And image height, it can be positive or it can be negative. When is it going to be negative? When it is real. Okay. When is it going to be positive? When it is virtual. Is that okay? Now we are doing lens formula. As we have a formula for spherical mirrors, we also have a formula for spherical. This is done, no? 1 upon V minus 1 upon U is equal to 1 upon M. That we have already said. How will we remember that there is a minus sign? Lens. L mein niche is a dash there. So the dash looks like a negative. Look at the last few lines. Okay, will you read last the lens formula?
The lens formula given above is general and is valid in all situations for any spherical lens. Take proper care of the signs of different quantities while putting numerical values or solving problems relating to lenses.
Yes. And we have also done about magnification. Is that okay? Come to the next page. Power of the lens. Are we ready? Basically coming back again to whatever we have discussed. We have already learned that the ability of the lens to converge or diverge the light rays depends upon the focal length. Correct? Converging, think of meeting. Diverging is moving away, the rays are moving away. For example, a convex lens of a short focal length bends the light rays through larger axes by focusing them closer to the optical center. Did we notice that? What's happening? The focal length is coming closer to the optical center. So what happens to the focal length? Is it long or short? It is smaller. It's definitely smaller. Okay. Similarly, a concave lens of a very short focal length causes a higher divergence than the one with a longer focal length. Underline from here. The degree of convergence or divergence of light rays achieved by a lens is expressed in terms of its power. Okay, power of a lens is defined as the reciprocal of its focal length. What is the meaning of the word reciprocal? 1 upon. Okay, it is 1 upon. It is reciprocal of focal length. It is represented by P, and P is equal to 1 upon F. Right there as M. All of you must remember, F always has to be in meters. Make a note of it. Write it in your textbook also. F has to be in meters. Arun, did you write? F. The measurement has to be in meters. Okay. What is the SI unit? Turn the page. What is the SI unit? Diopter. Okay, it is capital D, which is diopter. So whenever we write any number there, plus 2.5, minus 2.5, whatever, just put a D there to show that it is the power. Okay. Suppose I know the power, can I calculate the F? Obviously, you just have to change this formula that's I put up. F will come here. Okay, so if P is given, can I find out F? Definitely yes. Okay, so what will be F? It is equal to 1 upon P. That's one. Correct? But remember, F is given in what? Answer F will come in what? It will come in meters. So then in that case, what should you do? Convert it once again into centimeters. Sometimes it's okay to leave it in meters. But please be careful whether F you're writing something like let's say 25. If it is in centimeter, if at all they're asking you in meters, convert it into okay. Divided by 100. Is that okay? Okay. Come on, write it in your notebooks. One line, I just want you to write. Power of a lens. This is on page number 157. Make a note of it. The degree of convergence. I'm dictating, everybody please write. The degree of convergence or divergence of light rays achieved by a lens is expressed in terms of its power. Put the second point. The power of a lens is defined as the reciprocal of what? Reciprocal of focal length. And in practice, I know very important. What is the important point? Focal length should be meters. Please write down in bracket right now, though it's not given in the textbook. Remember that focal length should be in meters. Now, all of you please write down the formula. P is equal to 1 upon F. Okay. What is the SI unit of power? Diopter, right up. Next point. The SI unit of lens is capital D, which is diopter. Next page. SI unit of power. SI unit of power is diopter. Okay. If this is negative, what does it mean? And if it is positive, what does it mean? What lens are we using here? Okay. Think and answer. Okay. Some people are sure. Very good. So it is concave. And if you know one, the other one is going to be convex. So it is going to be convex. So just make a note of this. Okay. Power of a convex lens will be positive. And power of a negative. If it is negative, we know that it is concave. Okay. Now let's look at this formula. P is equal to 1 upon F, and we know that F is equal to in meter. Suppose I say P is 1 diopter. What does it mean? What does it tell us about the focal F? If I say somebody is having or using glasses with 1 meter, what is F?
1 meter negative.
Is it going to be 1 or is it going to be 2 or whatever it is? 1. It is going to be 1. And it is in centimeter, meter. That's it. So this is going to be 1 meter. Can you understand? As simple as this. Okay. So if you take a lens of focal length having 1 meter, that means to say its diopter is 1. Okay. So what is 1 diopter? It is 1 meter inverse. Did you get it? Okay, so it is 1 meter inverse. That's all. Look at the next page. The same page. Did you see the SI unit here? Can you all see this page? The SI unit of power of a lens is diopter. Underline the word diopter. These are some of the words that we must remember. It is shown by the letter D. If read, see. Second line. Read.
If F is expressed in meters, then power is expressed in diopters. Thus, 1 diopter is the power of a lens whose focal length is 1 meter. 1D is equal to 1 meter.
1 meter inverse. Why did we take it as inverse? Because meter F is in the denominator. That is why it is meter inverse. Yeah.
You may note that the power of a convex lens is positive and that of a concave lens is negative.
Underline that. Anyway, it is given in italics, but you must remember that positive for
Convex.
convex and negative for concave. Very good. Okay. Okay. Now I am giving you one simple thing. Come on, write down. Yes. Find the focal length. Find the focal length of a lens whose power is 2 diopter. I'm not even putting this side. Look. Do this. Substitute and sorry.
0.5.
The power is 2 diopter. Find out.
F is equal to 0.5.
0.5. We all get it as 0.5 meter. Is it plus or minus? Plus. You didn't understand? Got it? This is how it is, no? Okay, P is equal to 1 upon F. P we know that it is equal to 2.0. It is equal to 1 upon F. So you just change it. F is equal to 1 divided by 2. 1 by 2 is nothing but half. So it is 0.5. So this is in meters, remember. Okay? F will be in meters. So that's equal to 0.5 meter. Convert it into centimeters. What will you do? Express your answer. Suppose they have given it the sum. 0.5 meters. Express your answers in centimeter. Yes, 50 centimeters. Write down both our answers. So what will you do? 0.5 meters times 100 centimeters. So that will be 50 centimeters. Tell me whether it is a convex lens or a concave lens. Yes, we are using a convex lens. Okay, why? Because it is positive. Very good. Write down that point first. So therefore, the lens used is a convex lens. No? Okay, take down the next question. The focal length of a lens is 0.40 meter and negative. The focal length of a lens
Yes.
find power. Only one formula you have, that's all.
Theta is equal to 1.
Ma'am, will it be positive coefficient like on the left side?
It's negative.
No, on the
No, no. Yeah. The same sign we go. Not positive, will not become positive. If it is negative, this will be also negative.
Minus 0.40 meter.
One,
Power 1/6.
do that. You can't keep it as a fraction. You have to give it to me in decimal point. Wait, what happened? What is the answer?
No.
0.40.
Minus 0.40 minus
0.40. 0.40.
What? Meters. Okay, if it is comfortable for you, can you convert it into what do you want to do? You want to do it in, but we want power now. That has to be done. What you can do is, if at all it is comfortable for you, convert it into centimeters. Then the answer also get. Yes. Yes. Correct. It is 2.5.
How is it 0.40
See, power is equal to 1 upon F. Correct? So P is equal to, what is F? It is equal to 0.4. This is in meters. Okay? So what are we going to do? You can keep it this way also. How will you shift this thing? You shift it by 1. You shift. It is going to be 10 divided by 4. How much is 10 upon 4? 5 by 2. It's 10 by 2. Huh? Into 10 times 10. So it is 10 by 4. That is equal to 5 upon 2. That is equal to 2.5. So many times this. Did you all get it? See? You just have to shift numerator, denominator, multiply by 10. See, I've written here. All of you pay attention. So 1 minus. I'm putting. Okay, this point is there. How will you shift the point? Multiply 10, multiply 10. So the point is gone. So you will get it as 10.4. 10 upon 4. So 5 upon 2, that is 2.5. Remember that this focal length was negative. So the power is also going to be negative. You get it? So what type of a lens is he using?
Concave.
Concave. Very good. Please write down then. Okay, the lens used is concave because the power is negative. Minus. Krishna, read that. Here. I'm reading this paragraph, second paragraph. Look at me here. Here.
Yes.
Okay, read.
Opticians prescribe corrective lenses indicating the powers. Let us say the lens prescribed has power equal to plus positive 2.0D. This means
Means what?
that
Diopter.
this means the lens prescribed is convex. The focal length of the lens is positive 0.5 millimeter.
Did you do this now? This is the same sum argument. Okay, they have just given you as it is 2D. So how did we find out whether it is 0.5? Obviously we have substituted. Okay,
Similarly, a lens of power of negative 2.5 diopter has a focal length of negative 0.40.
I have given you that. Okay, I have given you the other way around. I have given you the focal length. Asked you to find out the power. That's the same thing. What is it? Did you understand how to do it? Okay, yeah.
The lens is concave.
Did you all understand? So this is basically about power, and in many of the scientific equipment that we are using, sometimes you may have to use two different types of lenses. Let's say, for example, a telescope, okay, or even a microscope. Have you ever handled a microscope in your bio lab? You know how it looks? There's a long tube, okay. So one is your eyepiece and the other one is your objective. Both of them are convex lenses. So you need to find out, suppose you're looking at some bacteria or some, whatever it is, maybe it's a spirogyra, whatever it is. It gives you a magnification, which takes the magnification of the eyepiece as well as the objective. If you understand. So that way, when we are calculating the power of many different type of lenses, maybe there's a 2 or 3. So the total power is equal to the power of the first lens plus the power of the second lens plus whatever it is, 3, 4, whatever it is. Okay, so what do? P is nothing but a total power of all the lenses that we have used. Remember, if it is a convex lens, this P will be positive. Okay, if there's a convex and a concave lens, then maybe this will be plus whatever it is, negative 2.5. This has to be taken into consideration. Did you understand what I'm saying? Okay. So if this is a convex lens and the other one is a concave lens, what is the value that I get here? Negative what? Yes. So the value here is negative 0.5 T. Now will the combination like this act as a convex lens or is it acting like a concave lens? What is the sign here? It is negative sign. Therefore, a combination of such type of lenses may act as a negative. So once again, when you do the problem, be careful of your negative sign, positive sign. Sometimes if there are two positives, obviously it's going to be a positive. If there's one negative, one positive, it's nothing but simply match here. Okay, but only thing is, they will ask you whether it is a concave or it is a convex lens. Is that okay? Clear? Okay. The box which is given here, read better. Many
optical instruments consist of a number of lenses. They are combined to increase the magnification and sharpness of the image. The net power P of the lenses placed in contact is given by the algebraic sum of the individual powers P1, P2, P3 as P equal to P1 plus P2 plus P3.
Underline this. The net power of the lens placed in contact is given by the sum of the algebraic sum of the individual powers.
The use of powers instead of focal lengths for lenses is quite convenient for opticians. During eye testing, an optician puts several different combinations of corrective lenses of known power in contact inside the testing spectacles frame. The optician calculates the power of the lenses required by simple algebraic addition. For example, a combination of two lenses of power 2D and 0.25D is equivalent to a single lens of power 2.25D. The simple additive property of the powers of lenses can be used to design lenses system to minimize certain defects in images producing a single lens. Such a lens system
Produced by a single lens. Sometimes if you are using a single lens, it can cause what is known as a chromatic aberration. So in order to minimize it, we usually use a combination of 2 or 3 different type of lenses. Okay.
Such a lens system, consisting of several lenses in contact, is commonly used in the design of lenses of camera microscopes and telescopes.
Please underline that. So where do we use such a combination of different type of lenses in different type of, yeah. These are some things that we already know. Okay. Microscopes, telescopes, which is using the combination of different type of lenses. Okay. Look at the questions there. Okay. Third question. Come on, do it. Find the power of a concave lens of focal length 2 meters.
0.5.
What is it?
Minus
Yeah, you have to tell whether it is positive or negative. Concave lens. Okay, so it is going to be negative. Okay, so your focal length was what? 1/2. This is given as 2, so obviously P is equal to 1/2. 1/2 is equal to 0.5. And it is negative 0.5. So if you have written as 0.5, no marks. Okay, do you understand? Though you have done all the calculation, absolutely no marks because you have not identified that it is a concave lens. So be very careful of this, putting that minus plus very, very important. There, come here. Okay. Question number 17. 17. Do that. Doctor has prescribed a corrective lens of power 1.5. So what is given? We want in the same format. What is given? Power is given. You have to find do that. One point five will not be 2 meters.
0.6.
6 recurring.
Why?
0.6.
1.5.
0.6.
100 upon 1.5. 50.
0.6.
Yes.
Complex.
Have we done this example 9.14? You remember we have done it? We have done it? Anybody has that volume? Volume 1 I want. Hey, no, volume 1.
Volume 2.
Ma'am, 2/3 is equal to 0.67.
Okay, write down this. There are quite a few questions here regarding the last part of the thing, you know. Regarding okay. Okay, there's one. Let's take down this. I'm giving it to you from here. Okay. Two convex lenses. Ready? Two convex lenses. Write neatly because two convex lenses, each of focal length 20 centimeters. I'm reading from here. I'm reading the copy that. Each of focal length 20 centimeters are kept in contact with each other. Okay. Find the power
0.40.
of the combination. Don't be in a hurry. Don't be in a hurry. Do properly. Use the formula and do it.
Focal length will become 40.
I don't know. You calculate. Use the formula and do it. How can you do it as 40? 1 upon 20 plus 1 upon 20 is 40. Okay. Be careful of the steps. What is it that I have told you? You cannot keep it in centimeters. It has to be in meter. Do. Tell me the final answer.
5D.
Final answer. What was my question? What is the total?
10. 10.
Understood what has to be done. Okay. We want to find out P total. I am putting it as, or F I can put, or P final. Okay. So P is equal to what? I have got as P1 plus P2. Correct? P1 is not given to us, but we have to find out what is P1. So what will it be? It is equal to 1 upon F. So it is equal to 1 upon F of first one plus the second one. Correct? All these steps have to be shown. In our case, what is it? F1 and F2, both of them are same. So it is equal to 1 divided by, that is in 20 centimeter. So I can write it as this. Look at the board. Look at the board. This is a simpler method to show conversion in meters. Does it make sense to you now?
Yes.
Okay. So instead of writing 20 centimeter divided by 100, what would I do? This invert. Okay, so that makes it 5. Okay, that will also be 5. So therefore, your answer will be there. Did you understand? Yeah, here. So instead of writing 1 upon F as 1 divided by 20 divided by 100, what does it mean here? 100 goes on the numerator, 20 remains here. So that's a very simple method to do it. Is that okay? Whenever you are given in centimeters, suppose I am giving you F is 25 centimeter. Okay, what will I do? 1 upon F, if I want to write it down, it means it is 1 upon 25 divided by 100. I am converting it in meters. How much will that be? 100 goes in the top, so it is 100 by 25. Okay, that makes it 4, and that is in meters. That is a power. Power will be, of course, diagonals. Is that okay? Now, there's another one. These are all very simple, the same thing as what I've done. Calculate the power of a convex lens of focal length is 40. Will you be able to do this? Come on, take down this. The focal length concave lens, underline concave lens is 30 centimeters. Okay, all of you think, don't tell me that it is like concave, concave.
30.
30, 30,
length is
30 centimeters.
Well,
Okay, now I'm putting down the data here, you can just record. Okay. Focal length, concave lens, they have already given you, right? Focal length is 30 centimeters, right? Find the position of the image. Find position of image of an object placed at a distance of object which is placed at a distance of 90 centimeter from the lens. What is this? What is this 90 centimeter? What have they given you? Object distance, isn't it? So this is object distance. So what alphabet will you use here? Well, come on to what formula will we use? F is there. Here U we know. B we have to find out.
1 upon B
No
minus
magnification.
1 upon B minus 1 upon B.
Correct. 1 upon B minus 1 upon U is equal to 1 upon F. Be careful of the signs here. Concave में F क्या होगा? What is F? Positive or negative? Negative. U will be negative. Come on.
B plus
So 1 by B minus 1 by U is equal to 1 upon F. We have to find out image B. So 1 by B is equal to 1 upon F plus 1.
Something 0.02. 0.02.
See your decimals. See your decimals.
0.02 something. Minus 0.02.
How can it be 0? You're finding out B, no better. Yeah, so how can it be 0.02? It is so small.
1 upon 45. 1 upon 45.
Who read that properly? Why it is 45? Why will it is 45? Okay, so that was, this becomes plus. Substitute the value. F is equal to negative. Plus 1 upon U, but U will be what? What is the value of U that you are taking? Negative.
90.
U. Yes, it is negative.
B is equal to 22.5.
Very good. Positive or negative?
1 cube negative.
Even otherwise, you should get it as negative. In your sum also, you will get it as negative. Show your book. 22.5 is correct, but I just want to make sure you've done it right. Here you've gone wrong. See here. You have written it as 1 upon F plus 1 upon U. Okay, when you put this plus sign, this is negative. F is negative. And 90 is also negative. That is where you made a mistake. Go here for the final answer. You can't just put a minus here.
Minus 2. How much you get?
Minus?
2.2.
Do. Correct. You're coming closer. 90 divided by 20 minus. Minus 20. Correct.
Minus
Negative, you get it as negative. You should get it as
0.02. Right, what's the 992 is 18.
Yeah, 0.0 I'm getting.
You're making a mistake with that. See here, F is negative. Okay? So here it is minus. Correct? This is a positive sign, we should put it. What is U there?
0.90.
Minus. Did you put it as minus? This minus and this, what will it become? So this is minus, this is also minus.
Minus 4.90. Minus 4.90. Minus 4.
Did you get it this way? Did you get it? This is where many of you may be making a mistake. 1 minute, please look at the board, everyone. Please look at the board. This is the formula, right? 1 minute. Just wait. What I'm saying is, it could be a very simple thing as this. This is the formula. We want to find out 1 upon V. Okay? So, this U here will become plus. Okay? When we are substituting the values, don't forget that it is a concave lens. This is going to be negative. Okay? This plus sign you're not going to change. It's still going to remain as a plus sign because it's a part of the equation. But here when you're substituting for U, once again look at the information given. That is going to be negative. Object distance is negative. So we put a negative here. So these two will once again become a negative. Okay, so that's why your answer B will come as negative whatever. 22.5. Okay, B is equal to 22.5 meter or centimeter? This is centimeter here because these are all in centimeters. You understand? How many of you got the answer at the first shot? You made a mistake somewhere. Okay. So what we need is plenty of practice. Okay. Sounds pretty easy, but a practice. Okay. Thank you.
Hey, so, dude.
Thank you, class.
Thank you.
Monday we have a class, huh? Don't forget. You will check your timetable because last minute there could be a slight change or whatever. Make sure, check your timetable and come on Monday, even I'm not very sure. 99% it's going to be my class. Going for a class or coming back from a class?
No one.
Around only 100
मेरा फोन करेगा
थोड़ा मेरे को लगता है मेरे को
देखा नहीं आया
आज मैं देखा फोन याद आया तो खाली
भाई शिट भाई देखो फोन
मेरे सब ये रहता मैंने
भाई मेरे को प्लीज हर दिन यहाँ पे एड्रेस नीचे देखने का प्लीज
हम भी मोबाइल कैसे
मैं जल्दी कैसे पैक कर दिया भाई
नीचे नहीं रखती चल देखो
प्लीज भाई ना मेरे को याद दिलाने तो एक दिन मैं फोन छोड़ के जा रही हूँ एक्चुअली इसलिए याद दिलाया
सब छोड़ दिया भाई
खुद को भी छोड़ देंगे एक दिन